Okay, so let's do a parallel plate practice problem. Here's an example of one use of these. A tiny ball, mass 0.016 kilograms, carries a charge of negative 16.9 microcoulombs. What electric field, magnitude, and direction is needed to cause the ball to float above the ground? Okay, so let's first take a look at this situation. If we're going to float above the ground, see, turn on my pen here. If we're going to float above the ground, the first thing that we're looking at is that this charged particle is going to have balanced forces on it, which means that the gravitational force, F sub g down, is balanced by some upward force, and the force that we're looking for here is the force from the electric field. Oops, let me make that a capital E. All right? And so that's what it's basically saying. Well, we know that if we're going to get an upward force on an electric field, the electric field is determined by the direction of the acceleration of a positive test charge, and so the negative charges will go opposite this, so that means that I'm looking at a field that's actually directed down. And if I have a capacitor situation with the field which is directed down, then it would exert an upward force on a negatively charged particle. So those are the first things to kind of look through. So recall here we're given that the mass of the object is 0.016 kilograms. We're given that the charge Q is minus 16 times 10 to the negative 6th coulombs. Again, you've got to know those prefixes. Recall for, let's see, the local G is 9.8 meters per second squared down. And we're asked to find the magnitude of the E field. Our formula that we're going to use here, we're going to use F equals mg, because that's the gravitational force on an object, and we're going to use E equals F over Q, because that's the relationship between the electric force and the electric field. Alright, and so my work is pretty straightforward here. The first thing I'm going to show is that the sum of the forces are equal to 0 here, which means that F sub E is equal in magnitude, if you want to do this from the first semester, to F sub G. So that means I can substitute F sub G right up in here. So let's just do that in one step. E equals mg over Q. If, here we go, we substituted that in there, and now we're just going to solve, because I have everything else. So E equals 0.016, and again, you should be doing this in your notes with me, times 9.8 meters per second squared down, and divided by Q, which was 16, times 10 to the negative 6th. So we're going to stick that in our calculator. Again, this is a 16, sorry. And you should find that your electric field is equal to 9.23, 23 times 10 to the negative, 10 to the 3 newtons per coulomb down. The field is directed downward. Okay, that is the first practice problem.